Anyone that's been watching my videos might recognise this machine. For those that don't, it's a Mimi 803. It's a machine I repaired a few months ago, and I got it up to the point where it was booting up. We were getting the startup screen, but I didn't have any floppy disks to boot from, so I don't have the operating system for it. But in the final video in the last series, I did show the monitor program where you could enter data using the keyboard, and it was very basic, but it did at least prove that the machine was working at least up to a certain point. But without the operating system, of course, you can't really go much further. Now, of course, I've got this upside down just so I can demonstrate what I'm doing here. I wasn't initially going to make this video, but a comment from a friend a little while ago mentioned that he sometimes uses one of these, and I realised I'd never shown this. So I thought I'd take the opportunity in this video to just demonstrate this in use. I'm not sure at the moment how involved this series of videos will get. From previous experience, I suspect it will get quite complicated. But in short, a very kind gentleman sent me a copy of the files for the boot disks for the Mimi 802. Now, I've got no way of knowing if they are compatible with this machine. I don't have any documentation for this. This is the 803. I don't have any documentation for the 802. So whether it will boot from these images or not, I don't know. But the way that these work, this is a Gotek floppy drive emulator, and if you're not familiar with these, then they're quite clever devices. They allow you to store disk images on a removable media, so a flash drive, and they then present that data or the image that you select as if though it was a floppy disk to the host machine. Now, because there are so many different variants of floppy drives, disk formats, etc., then the Gotek has a configuration file system where what you can do is, in the root of the image, so if you imagine this is just basically a flash drive memory stick, you copy onto it the image of the disk that you're trying to emulate, and then you modify a configuration file to tell the emulator the parameters for the disk that you're trying to emulate, sectors, skew, that sort of thing. And then in theory, what comes out of the back, it's a standard connector, should be presented to the host system in such a way that the host system thinks it's talking to a floppy drive. And so in theory, what you should be able to do is put the boot image on this emulator, connect it up in the usual way, and then the host machine should boot. So as I say, this is upside down, and I've got it all connected up. I've temporarily attached a button onto the bottom of the keyboard. This button's not normally here. This is just attached across the B key, and if you did see the previous videos, you'll know that when the machine is in its boot up screen mode, you're in the monitor program, and the B key in that mode will try to boot from the floppy drive. So I've got this plugged into floppy drive A port. So if I press the button, the machine should boot up. Okay, so I'll now try to boot up the machine. We can see that the emulator is being accessed. The drive light, the LED on the front of the emulator, is the same as the drive light on a normal floppy drive. So whenever this is being read, this light should come on. If I press the B key, you can see the light does indeed come on. So this is at least trying to be accessed. However, I'll move the camera so you can see the screen on the output of the Mimi. Okay, so as you can see, the machine is not booting as it is at the moment. I'll press the B key again. You'll see it's going through the attempt to boot, but it is coming up with unable to read this system disk. So I'll move the camera back so you can see the machine again. Okay, so looking back at the machine, now I have spent some time checking the configuration of this. I've tried various configurations. Of course I don't know what the format is for the disk, so I've been having to try and guess. And the way I've been going about doing this is looking at the signals going into the floppy drive controller, which is this device here. Anyone that's interested, it is an FD1797. Very similar device to the one that we were looking at on the Wren. These are just far easier to get hold of. And if we look at the spec sheet for this device, one of the important things we want to look at here to start with is the raw data coming into the device. So where it says here raw read, that is the raw data coming in from the floppy drive, and that's the data that the floppy drive controller chip will be trying to slice and turn back into data. So hopefully you can see the scope in the background. If I press the B key, we should see data coming from the floppy drive, which we do. Okay, so at least we're getting data coming through. Now I've been through this before I started the video and looked at the various signals. And there are some strange things going on with this, but fundamentally it looks to be doing what it should. And the way that this device works is once it's decoded a byte of data, then pin 38, which on the spec sheet is shown as DRQ, should change state, and it does that to flag to the host machine that there is some data waiting to be read. So if we monitor that, and I press the B key again, we notice that nothing's ever happening, the scope isn't changing. So though it's going through all the motions, nothing appears to be being decoded by the floppy drive controller. And as I say, I've checked all these signals, making sure the clock's there, it's the right frequency. For this sort of drive it should be 1 megahertz, which it is. Everything else is there, the data bus is working, read write is being accessed the way it should. So the question is what to do next. Now it could simply be that the image is not compatible with this machine and the message is unable to read in this system disk. So on the face of it, it looks like it's just a case of this is not the correct system disk. However, if I put in just a random image that has nothing to do with this machine, or if I misadjust the configuration file so that the disk can't be read at all, I get exactly the same message. So I think that message from the MIMI is just the default can't read disk message when there is something there. Now if there's no disk there at all, I get a different message. So it just seems to be when it can't read the disk at all, that's the message that it throws up. I haven't looked into this in any detail yet, so I think that's really the next stage. I'll have a quick look around, see if I can figure out what else is going on. As I say, we're not entirely sure this is the correct image, the boot image for this machine, but it should still be reading something because it's not going to know it's not the right image until it starts to read it. But as it's never decoding a byte of data, then I don't see how it would know it's got the wrong image in there. Now one thing that's important to understand when you're dealing with floppy drives is the data is not just a continuous stream of bytes of the actual data. I won't go into it in a lot of detail here, but in short, the data has it's broken into blocks, and each of those blocks has a header at the beginning, and the header indicates several things such as the length of the block of data, quite a lot of other information, some number of bytes, and the type of formatting for the data. And so when the disk is being read, there's quite an interesting and fairly complicated mechanism going on. So if you imagine this was a physical drive, then the disk itself is divided into rings, and they're called cylinders. Those cylinders are divided into segments, which are called sectors, But as you get away from the center of the disk and start getting further towards the outside, then obviously those sectors are effectively passing under the read-write head much more quickly. And so there are various things you could do. You could ignore it, like you do with an LP record, and just accept the fact that it's a fairly inefficient way of storing data on the record, because you have to decide which part of the system you're going to sacrifice quality against storage capacity for. But with something like a floppy drive, where you're trying to maximize the amount of data you can store on here, there is a more complex mechanism going on. Now, this explanation won't be complete or particularly accurate. I just want to give you an idea as to how it works. But the floppy drive controller is trying to slice data. So as the disk is spinning and data is being read, it's being fed into the raw data input of the controller chip, and that's trying to turn that data into actual binary bits. And to do that, it has to know how long to wait to determine whether the flux on the disk is a 1 or a 0. And how long it waits, in theory, should change as you get away from the center of the disk, because, as I said, the disk is spinning faster, so in theory you can store more data out there. So most floppy drive systems are fairly dynamic in that they are controlled to a certain extent by the data stream coming from the disk. So when a header is encountered, it's essentially timing how long it's taking from one header through the data stream to the next header, etc., and so on, and it's using that information in part to determine the data slicing frequency that's used by the floppy drive controller chip. So in other words, it kind of locks into the right speed depending on the data and the format of the disk. It's not quite as simple as that, but just bear in mind that the clock can be fairly dynamic in the way it's used in a data slicer on a floppy drive controller. So that means that if you put the wrong format disk in, or if you tell the emulator the wrong format for the disk, then it's not necessarily going to be able to detect the data. And because there's a CRC checksum associated in the header for the data, then when it reads the sector, if it's read it incorrectly because the speeder was wrong or the slice frequency was incorrect, the CRC checksum won't match, and it will just reject the data as if though it hasn't read it. And that could be what's going on here, that we've just got the wrong format, or it's the wrong image and it's just not going to work on this machine. But obviously I need some way to test all this. So the first thing I'm going to do is have a look around on the circuit, see if I can find any faults, because this still could be a hardware fault on the machine, and I'll get back on camera and we'll see if we can get any further. So I've been having a look around the board, and as I say, I don't have a schematic for this, and this is one of the problems dealing with old machines like this. Schematics are worth their weight in gold when you're doing this sort of thing. It can save you a huge amount of time. But looking around, I couldn't quite figure out what was going on with this device. There is a pin on it that is used for several different functions, and on the spec sheet it's shown here as WF VFOE, and it's used for different things depending on the version of the device and the format, or rather the mode that you're running the chip in. And it seemed to be doing odd things. I thought it was a faulty device at first, so I tried a different device and it did exactly the same. But looking around, one of the usages for this line is to control an external data slicer. So I started thinking, well, does this machine use an external data slicer? So looking around, normally they're fairly close to the floppy drive control chip. I couldn't see anything. I got right over here. I have to move the camera so you can actually see it. It's quite a long way from the floppy drive controller chip. Okay, so when I got over to here, I noticed a couple of things to start with. A couple of pots, which are quite interesting, and if you're familiar with this sort of thing, you'll understand that seeing these pots could well mean they have something to do with adjusting the data slicing for the floppy drive controller. But more interestingly, I found this WD1691V, which I do know is part of a set of chips that are quite often used, and this is used as an external data slicer for the FD17 series of floppy drive controller chips, and that's normally used in conjunction with a clock generator chip, and sure enough right next to that is the clock generator chip. So I've pulled out the spec sheet for this device, and that's this device. And so what I'll do is just go to the example schematic that they give. As I say, I don't have a schematic for the MIMI, but if we look at the schematic in the datasheet, quite often designers would just pretty much use these exactly as they are in the examples given by the manufacturer of the chips. So we have exactly the same devices, and the way this works is when the data's coming in from the floppy drive and it comes in up here, it is going to the raw read. That's what we were seeing, the raw data going into the 1797, but it also goes into the 1691, and this is acting as the actual data slicer, and because of that it is responsible for modifying the clock speed depending on the data stream that's coming in. And to do that, it uses a voltage controlled oscillator, and that's an external device, and in this case it's showing in the example a 74LS629. So I thought, well, let's have a look around, and sure enough there's an LS74629. So looking at these as a set, they seem to be mimicking this. Now looking around, the pin outs are all different. It's not connected as it's shown on here, but I suspect that it is this circuit just in a slightly different form. So if we start looking at the data coming out, so looking around tracing this out, I found that this it's saying 4 megahertz here, but for the drive type we're using it's actually 2 megahertz. If we look at pin 16, that is actually connected to this test point here. So what I'll do is I'll connect the scope to that test point, and what we can see on the scope is it's saying 1.73 megahertz. You probably can't see that, but the disk isn't spinning, so though it should be 2 megahertz to properly data slice this format of disks, I've still got the emulator connected. If I press the B key, if this circuit's working at all, we should see the voltage controlled oscillator taking control by virtue of the data that's being sliced from the incoming data stream, and it should modify the frequency that we're seeing on the scope. I'll just raise the camera very slightly so you can see the scope a bit better. And what I'll do now is I'll press the B key, and we should see that the frequency on the scope is modified, and indeed we can. It's gone up to exactly 2 megahertz. Now I have been playing with this for a few minutes and it was off quite a bit. It was going up to about 1.8 megahertz. So there are two pots here. One's for pre-compensation adjustment and the other one is for the frequency of this clock. If you do adjust this, it is important to adjust it while the disk is being read, because that's when the voltage controlled oscillator circuit is active, and it's then adjusting the frequency to match the format of the disk. Now of course, if the disk is the wrong disk and it's the wrong format and you adjust it, it's still not going to work because it's not going to be able to properly slice the data coming from that disk. But just to give you an idea of how this works, if I turn this pot, you can see that the fundamental frequency is changing, so it's dropping. It's now 1.3 megahertz. If I press the button again, you should see that frequency change. It's 1.3. It's now jumped up to 1.5, but it's all over the place. It's going up from 1.3 to 1.6 because it can't lock in. There's only a certain lock-in range that the circuits have. It's fairly limited. I think it's about plus or minus 15%. So we'll go back to approximately the right frequency. I'll press the button again, and while it's reading I can adjust the frequency till it's shown exactly 2 megahertz, which is there, and that's now the correct point for this disk type. But as I say, I don't know if the image I've got all the configuration file in the emulator is correct. So the circuits seem to be working. I can't find anything else wrong in here. It's reading data. The output on the floppy drive controller pin that's supposed to indicate when it's successfully decoded data is still not changing, and I believe that's still supposed to be operative when it's using an external data slicer. These two devices are kind of talking to each other, and then the interface to the processor is still from the floppy drive control chip. It's not from this device, and the clock chip is simply talking to the data slicer to work in a kind of closed loop to make sure the frequency of the data slicer is correct. But because we're not getting any data out of here, then there could be something else going on here. The fact that it is able to successfully lock in at one point here is that when it's close to the right frequency, instead of it wandering all over the place in terms of frequency while it's reading the disk, it locks in very precisely to the right frequency, and that's what we saw. So it does tend to indicate that this circuit is working, that the floppy drive controller chip is working at least to a large degree, and as I say, I have tried a new one and it makes no difference. Could be a problem with the emulator, but because we're seeing data coming in successfully, I don't think it is that. So most likely the image for the disk that we have, or the format of the disk, doesn't match what this machine is expecting. So luckily the gentleman in question that sent me the image has got some of the original disks. Now they are for a MIMI 802, so as I say, I don't know if that is the same disk format, whether it uses the same drives as the 803, but the next step is to try an actual disk. So he's running off some copies of the disks for me, and when they arrive I'll pop one in, plug the cable back into the actual physical floppy disk itself, and we'll try the same thing and see where we get. So I'll do that in the next video. In the meantime, any comments are welcome. If you've been through something like this and you think you know what the issue is, then please leave a comment, but I strongly suspect we just need to find the right disk image, and then in theory we should be able to boot this machine, which would be quite a nice thing to do.